This is lesson 10-7, areas of circles and sectors. So we're first going to start off with the formula for area of a circle. Area of the circle is the product of pi and the square of the radius. And you guys know this better as area equals pi r squared. So I take the radius and I square it and I multiply it by pi. So area of a circle is pi r squared. So in order to find the area, you have to have the radius. Okay, so if they give you the diameter, you're gonna have to take half of that, but you need to know the radius in order to find the area of a circle, and then we multiply it by pi. Sometimes we multiply it out, and it tells you there you're told how to round it off, and other times you just leave pi as your answer. So let's find the area of this circular region on the wrestling mat. So you can see since the whole line is drawn, then the diameter is 32. So I write down my formula. Area is pi r squared. I'm going to substitute in my radius, so that's really the only thing that you need to know. If the diameter is 32, then the radius is going to be half of that, so my radius will be 16. So pi times 16 squared, and at that point you can just do it into your calculator. So I'll get 256 pi and 804.2477193. Okay, so the area of the wrestling region is about 804 feet squared. You'll be told how to round it off, whether I want it to a whole number, the tenth, or sometimes you're actually just going to leave it just like this, 256 pi. So if they say leave it in terms of pi, you're multiplying just the numbers and you leave the pi. Now this is going to be new, the sector of a circle. The sector of a circle is the region bounded by an arc of the circle and two radii to the arc's endpoints. So it's a region bounded by an arc of the circle and the two radii to the arc's endpoints. So I'm going to have an arc of the circle like arc AB and the two radii. So I have a radius OA and OB. So it's this yellow shaded region right here. That's considered a sector of the circle. Okay, so it's sort of like a piece of pizza. Now the area of a sector of a circle equals the measure of the arc over 360 times the area of the circle. Measure of the arc over 360 times the area of the circle. This actually makes sense because if I want to find just the area of the shaded region, it's a portion of the circle. What portion of the circle is it? Well, the length of the arc, the measure of the arc over 360 is the fractional part of the circle that shaded region is, and I just times it by the whole area of the circle. So you're finding the area of the circle and you times it by whatever fractional part that sector is. And I find that by the measure of the arc over 360, that's the fractional part. Okay, so that's the area of a sector. So if I was looking at this picture right here, the area of sector AOB is the measure of arc AB over 360 times pi r squared. So it's really not too hard. Let's try a problem with some numbers. Let's find the area of sector GPH, and I want to leave my answer in terms of pi. So the area of the sector is the measure of arc GH over 360 times pi r squared. So I have the formula for area of a circle, and then what part of the circle am I actually trying to figure out the area for? So the part is arc GH over 360. Well, you can see that arc GH is 72 degrees, so 72 over 360 times pi times 15 squared, because that's the length of my radius. And I'm just going to put that into my calculator, and I get 45 pi. So I multiply all the numbers but the pi, and my answer is 45 pi. Okay, so the area of sector GPH is 45 pi centimeters squared. All right, so sectors aren't too bad. We have another thing called segments. The segment of a circle is the part of a circle bounded by an arc and the segment joining its endpoints. So this right here at the end is a segment. So I have an arc and I have the segment joining its endpoint. So this is the endpoint of the arc, endpoint right here. So this segment, okay, is the endpoints of the arc. So this little yellow piece right here is the segment of a circle. How do I actually find the area of that? You're going to have to find the area of the sector, and then that line right there creates this triangle, so then you subtract out the area of the triangle and you're left with the area of a segment. So this one's a little bit trickier, but you're finding the area of the sector, the whole piece, and then you notice that that endpoint creates a triangle. You subtract out the triangle and you're left with the little segment that you're trying to find. So we'll do a tricky one together. I want to find the area of the shaded segment shown, and I want to round it to the nearest tenth. So remember, first I actually have to find the area of the whole sector. So the sector is the length of the arc, the measure of the arc, which is 60 over 360 times pi r squared. So the measure of arc AB over 360 times pi r squared. Now remember, this is a central angle, so if this angle is 60 degrees, then arc AB is also 60 degrees. So 60 over 360 times pi, and the radius is 18 squared. So I'm finding the area of the whole sector right now, and that gives me 54 pi. Now I have to find the area of my triangle ACB, and I will subtract that out to get that little tiny shaded area of the segment. ACB is an equilateral triangle. So if I were to draw this, and how do I know it's equilateral? Because these radiuses always congruent to each other. So if these are congruent, then these two angles right here, angle A and angle B, are congruent, so they have to be 60, 60, 60. Remember, area of a triangle is half base times height. So basically, if I drew the altitude, that's going to be a 30, 60, 90 triangle, just like we did in the last chapter a lot. So the area of the triangle is half base times height. The base is 18. The height is just going to be half of 18 radical 3. So half of 18, because that's the base, and then my height is 9 radical 3. So my area of my triangle is 81 radical 3. And here's a picture right here of that 30, 60, 90. Remember, if this whole thing is 18, then this little piece is 9. That's across from the 30. Then across from the 60 will be 9 radical 3. That's how I get that height. So now the area of the shaded segment is the area of the sector, which I found 54 pi, minus 81 radical 3, because that's the area of the triangle. And I'll just do that in my calculator. Okay, and they'll tell me how to round it off. So since they didn't say that, I'm just going to say the area of this shaded segment is about 29.3 inches squared. So that one's a little bit trickier, but we'll practice both of those tomorrow. Okay? And that's it for today. You can fill out your summary sheet, and we'll work on some problems tomorrow.